Hi, John.
We also use cell jammers so that nobody in the banks can call 911.
This crew comes in heavy, demanding all the money in the drawers.
Hi, Claudine. Sorry, I was on mute. Can you hear me?
Yes, we can.
Okay, cool. Awesome. Okay. And let me quickly see. I can share my slide as well, I hope. Okay, wait. I just want to... Okay, and can you guys see my slides?
What's your pitch?
Cool. Okay, guys, let's give a minute or two still. It is already been recorded, so no worries there. I'm going to share. I just also want to get into the chat that I can see it. Okay, so there's already the attendance register form is already there. I'm also just going to copy it into the chat again. And then hopefully these links will also work, but you can use any of the links. Okay, cool. Okay, just quickly let me know, can you see the presentation still? Just a thumbs up or thumbs down will work as well. Then I just need to see if there's something wrong on my side. Okay, guys, let's start, and people will join as they're joining. Again, there's links in the chat to the attendance register to complete. There's a link to the feedback form as well. If you are new today to this group, my contact details as well. I'll in any case load this presentation onto the Teams site as well. But we have a WhatsApp group So please, if you want to join, there is my contact details. Afterwards, so you can jot it down now. Afterwards, you can send me a WhatsApp, and I'll add you to the group. And in that group, we also do a lot of, we can have lots of discussion about the assignments and things that you are struggling with. Okay, so let me go into last week. We looked at the basically chapter 2, the simple interest and simple discount. Today, want to take it then a step further to look at compound interest, how to master that. Let's look at other interest rate formulas, and then next week we will start with looking at some of the annuities. And then I think in that week after that, there's a bit of a break because of a possible long weekend and things like that, with Heritage Day. And then the week after, we'll go into the sinking funds and amortization. Okay, so basically today, again, as my slides of last week as well, there's what I've basically did was looked at your study guide and the key concepts for myself. I took it out of there, and you will also see towards the end of the slide, so there's a few slides today, I also created again a basically formula page of the important formulas that are in this chapter. Again, as we go through and there's one or two extra that I need to add, I will do that as well. So basically in this chapter, and I think what I will do is, and that would be nice if you can just give me an indication of what calculators you guys are using. I think that would be important as we go along, so that we can just get to some of the work that we will also do on a calculator, so that I can just get an idea of what you guys have. It's always a possibility that one can see if one can do a video or something on how to use some of the calculators, and I can always post that as well. So it will be nice to get an idea of what calculators you guys are using. So also, because this is recorded, and the guys that will listen to this later on an email or in a WhatsApp, let me know, because I work with a HP, so I know there's Cashiers and Sharp and other calculators available as well. So it would be nice if you just communicate with me, and then we can see if I can get some of those, and maybe we can do one or two videos on how to use a calculator for some of the work as well. So basically, if we're going into compound interest, and there's a lot of definitions in compound interest, but the big difference between compound interest and simple interest is the simple interest, you invested an amount, and at the end of the term you get interest on it, where compound interest is basically, and the term they would tell you, and the interest rate they will tell you, but basically compound interest is you're getting interest on interest. So if the interest is calculated on a monthly basis, you will add that interest amount towards your present value. That new amount for the next month would get interest, and so it goes on. And that is why they always say to start investing early on a compounded basis is the best way, because when you get nearly the longer you keep the money, the more money you will have. Okay, so that's basically the reasoning behind compound interest. So when we start looking at the formulas, and let me just start working again. So basically in the formulas, as we had with a simple interest, it was that your future value will be your present value times your interest. And you will now see it's very much the same principle. The only difference is in how the formula is written, and basically where the time period was normally within the calculation when we had simple interest. Now basically with that it tells you that you are getting interest on interest. So again, when we look at calculators, that will be your future value, that will be your present value, that would be your interest rate. So dependent on what calculator you use, it can have different symbols to it, and that is also on your calculator. That is the time period. So basically, when we start working with compound interest, and from this point forward, we are able to use the financial calculators to do the calculations for us. So we still need to know the principle, and you will see that in a lot of the exercises, we will also look at, if you don't have a calculator, how to do it, but I'll also just write down what you need to look for in the calculations when you have your calculator with you. Also, I think always important, and again, that is how I do most of these problems as well, to draw your timeline. I think that is, again, just nearly to reiterate, whenever you do these problems, always try to draw a timeline for yourself so that you can see what you need to do. So let's go into one of the examples. I think it is also in your study guide. So let's look at what they are asking us. So they ask us to find the compounded amount on a 5,000 that was invested. So we need to find a compounded amount. So we need to find the future value. We have a present value for a period of 10 years. So we know that n is equal to 10. And you have your interest, and this interest rate is per annum. So again, it is easy to work with that. So it will probably be, okay, I must just now make sure that I'm doing my calculation right. It will probably be 0.075 if you look at that, or it could have been 7.5%. Okay, so we have a formula. I'm also just checking it on the calculator, and then I will also write down what I've done with a calculator. And also, I think what is important is that when we do this, so let's start. We have the present value, so you can put that present value into your calculator. It's always good that one of your values, and I think that is also just a note. And so if you make one of your values need to be a negative for the calculator. So if if you don't make your present value negative, your future value will be negative. So it's not that it's wrong. Just remember that when you're working with a calculator, that if you now suddenly see a future value that's negative, it is probably because when you input the data at the beginning, you didn't say that the present value was negative. You probably said it's positive. So it's not that your final answer is wrong. Just take away the negative and you will have your future value. So by using the calculator, present value is equal to 5,000 minus 5,000. The one thing that you always need to remember with a calculator is you always need to nearly clear all, and that is important also. So this was calculated per annum. So if you haven't done it, you just need to remember that there is a how many times per year function on your calculator as well. So if it is a monthly, we would have said 12 times per year. The default is 1. So if it goes back into, if you've cleared everything, the default is always 1. But otherwise, what I normally do is before I start, I will look at what is asked. So I know it's annually. So I would say how many times per year, it's 1. Then my N in the calculator, I would put in 10. My interest rate on the HP, so I am working with a HP 10. So my interest rate per year will be equal to 7.5. And then if I ask it for a future value, it will actually give me that same amount. So again, if we did it with a calculator in this format or with a formula, you will get exactly the same answer. And I think that is important. So quickly, if you want to, I know this feels way weird, talking and then can't see how everybody's working on their calculator. So if you have a calculator at hand and quickly want to do it and try it, please do. If not, we can go on to the next one. And let's see, I think we're a small group at the moment. So let me know how you find it on the calculator. If you have a calculator with you, what is happening on your side. So if you want to unmute, want to say something, or if you quickly want to type in something in the chat, please do. I don't have an issue at all if you want to do that. Yeah, it seems like we only a few, so I think we're only 5 at the moment. So otherwise we can just continue and I will go to the next one. So please, if there is questions, just stop me. So basically we and you will see what. Yes. No, it that's why yes, I nearly want to say if you can avoid doing it manually, please try to avoid it, because it's not that you will make a mistake using the formula, because you can just substitute, but it is so much easier and so much quicker to do it with a calculator. And that's why I nearly want to use this also as a way to show you how to use the calculator. And also that's why it would be interesting to know which calculators you guys have, so that if there's at a point that I need to show something, that we can maybe do a short video. Okay, so let's look at this one. to see if my, okay, so how much interest is earned? So I think this one is important. So interest earned, we don't normally have a interest earned on your calculator. So that's the first point. On 9,000 Rand invested for 5 years. So we have a present value of 9,000. Again, remember the negative so that the future value that will come out is positive. Over 5 years, so we know N is equal to 5 at the 8% per annum, compounded annually, so we know that it is happening once every year. So just luckily the previous one was also once per year. So if we did it without clearing the computer, it wouldn't have mattered. So what else do we need? We need the interest per year, which is for 8%. And then we will get a future value. Okay, so then we will get a future value. So let's, if you want to quickly test that on your calculators, the 9,000 negative will be your present value, will be 5 years. It will be once a year, 8% interest. And the future value that I get is 13,223.95. So I do get that. So we have a future value, but in this one, they ask us what is the interest earned. So then you basically still need to make this calculation. I don't, on my calculator, there isn't a button that I can press to see what was the interest that I received. So I still need to make that calculation of what was the future value, subtract what was the beginning value, and from there I can get the interest earned. So with a question like this, again, easier with a calculator to get to that future value, but you need to remember that you still need to just get the interest, so you need to subtract it. And once again, as I've seen some of the previous papers, what they will do in the exam is the future value will be one of the answers. So if you forget to subtract the interest earned, you will probably go for that future value. So just remember that always look at what the question is and what your answer is. Okay. Quickly, just one thumbs up that I can continue. If there's other question, then, but just quickly, everybody happy thus far, and give me a thumbs up or a thumbs down. Okay, I take it as no answer is also a good answer. Okay, so basically when we looked at that formula, that will be our main formula for most of this work. So there can be a few things that will change. So within that formula, what you see, what is happening here in these instances is, and we'll see it in the next few examples as well, is the basic formula is your interest per annum, or annually, the interest that you receive, and the N would be that annum in years. But then now suddenly they talk different languages and they start saying, okay, but what if it is happening monthly or daily or quarterly? And that is then where you start using one of the other formulas, basically to say, okay, well, if it is monthly, then my interest rate is divided by 12, and my M at that stage will be 12. So then you become that you use that formula, but in a different way. And that is why in these formulas, that M can nearly be a monthly, so that you divide it by 2. It can be quarterly, so you divide it by 4. It can be daily. We seldom have that, but it can be twice a year. So yeah, so it can be a few things, and I think that is just important that when you then look at that, so also remember then it automatically changes the number of times that this interest will happen. So, and you will see sometimes they have questions, and I think there was 1 or 2 in this one, is that they would tell you, okay, a bank is maybe, if you invest 100 Rand on a monthly basis, or you invested 100 Rand, you get interest monthly at 8%. Is that a better choice than you have put away 100 Rand? Your interest will be quarterly, but you will get maybe 13% or 14%. And they say it's over a 5-year term. So then it's nearly to say, okay, which one is the best performer? And that one is the one that you will go for. And every time the formula will be the same, but where you will change it is in the period that you use. So let's see if there is an example. So let's look at this one. And I'll also see if we can check how we can do it on the calculator. Again, this is weird that it's not in a class setup, but let me see. So let's see what they say. 2,000 Rand is invested at 14% per annum for 3 years. So we have a 14%, we have a per annum, we've got the 2,000. Determine the accrued principal of interest if calculated. So at this point, nothing has changed. So it is still per annum. It is over 3 years period. So we are using this formula. So let's do that. But you will see in this formula, oh, sorry, in this formula, and I assume that should have BTM, so I will just make that better. So your p-value stayed the same, it's with 2,000. If you look at the interest, well, the interest still is 14%, so there is for 14%. Your M is still 1, so it is annually, so nothing has changed. So you're actually just reverting back to your original formula, and your T is free. So let's quickly do what I would have done on the calculator. So my present value would have been minus 2,000, so that my future value will be a positive. My interest per year is for 14%. It is per annum, so yes, it is still in in the calculator, but it is 1 time per year. Then what are missing, it is n that is equal to 3. And then if we ask for future value on the calculator, we are supposed to get the 2963. So let's quickly check that. 2000 present value, it is interest rate of 14%. It is 1 times per year. It is 3n. So your future value that I get is 296.088. So round it up, it will give you the 0.9. Okay, so that is your standard one again. We looked at the different formula, but everything in this question was still basically looking at it at an annual basis. So let's do one that is not on an annual basis. So let me see if I can move that a bit to that side. So let's change this one. So Anelia, I want you to see if you can get to your calculators if you have. If not, I'm also doing it on my side. So let's say we're still working with a present value of 2000. It is invested 14% on a quarterly basis. So let's say it is quarterly. For 3 years, determine the accrued principal interest is calculated. So let's see what will the future value be of this one. So if it is quarterly, what will your M be? And you guys can put it in the chat or actually unmute and tell me. I think we're only 6 or 7 on the chat, so actually we can do this a bit more interactively. So what will your M value be? Okay, so your M value will be the 4, because your M value is the 4 on your calculator. It will also then change from a 1 time per year to the 4 times per year. Okay, so that is the place where it will change. Your N will still stay the same, and basically in the HB there is, if I use the second function and the N again, it will actually tell me that I am looking at 12 periods, and that is right, because if you are running it quarterly, it means there's 4 quarters a year. If you run it for 3 years, it is basically 4 times 3, which gives you a 12. And then if I then get my future value, let me quickly do that. So minus 2000 present value. My interest per year is still 14%, so nothing have changed there. I do it 4 times a year. I do it for 3 years. Then suddenly the answer that I get is that my future value is 3,022 Rand and 14 cents. So just by changing the way that the interests are structured, you suddenly get a bigger amount. Did everybody else try this as well and got the same answer, or struggling with a calculator or don't have a calculator? Just tell me, and we can just see where we can assist.
John?
Yes.
Hi, it's Craig here. So
Hi,
I
Greg.
got the answer, but what I normally do is I manually calculate the end period. So I will take the 3 times 12. I mean, 3 times the 4 to get to my 12. But is there a way on the Sharp calculator where I don't have to do that?
Okay, so that is so send me you are on the WhatsApp group.
Yes, I am.
Send me a pic of a shop so that I can look for you, because there will be. So it's not wrong what you're also doing. So that is definitely another way of doing it. And there's actually no issue with that. Because you can do it that way, because as long as you make that calculation yourself. Because again, when I look at the HB, because I could do the second function with the n that actually tells me how many periods there will be, it also tells me 12. So that's more for me a check-in that I'm doing it right. But perfect, you can do it the way you did it, but there will be another way as well. So I'll just later on just send me a pic of a calculator and I'll see how we can do that. But also with this course is, if you get the right answer, don't don't worry too much, because your method is also working. So, and I think if you do it that way, you will probably never forget to reset it to the 1 time per year, where I need to now again reset it to the 1 time per year as well. Otherwise, next question I will get it wrong. And this is also important because I have seen it, is that it can be, and specifically with some of the questions, that if a one question in the exam is maybe quarterly, and the next one is a yearly calculation, sometimes there is actually that answer that goes with a quarterly, so that when you haven't actually and it's scary that they actually work out the papers like that, but that if you actually have worked with your previous questions times per year, they sometimes are also a correct answer for you. So that's why I think it's very important when you use your calculator nearly to make sure that you reset it every time, or use the method that Greg is also using in a sense. Because I know in last semesters, the one class that we still could have face to face, there was one of those in the assignment that I worked with the previous percentage or the previous number of times per year, and there was an answer. So just be careful on that one. So let's go on to the next one. So basically, again, you will see that the formula stays the same. It's just that there's a few different ways of writing it. So as in the one that we did last week on simple interest, if I want to rewrite it in the format that I want the P, I basically need to divide on both sides with that. So that is why I'm dividing on this, what is it, right hand side with it. So the one that is left is P. I divide on the other side with it, so that will be then the formula that I will end up with. Then from maths way back is basically when and let's make it, when I had that 1 over 2, I could have rewritten it as 2 to the power of minus 1. So basically that is what is happening here, is that whatever was at the bottom you can bring it up next to the S, but then the N needs to just get the minus sign in front of it. So basically the same as what happened there, that is what's happening with this one. So that those two formulas exactly the same. And that's why nearly it is here. It can be confusing because now suddenly they've brought in the one that if you're working with different periods as well, but basically it's every time still the same formula that we started off with slide 7 nearly, that this is the formula that you work with and that you have started off with, and you can manipulate that formula then. So let's go into the next calculation. So again, timeline. So let's look at what we need to get. I just into a room. Okay, so they're asking us what is the present value. So here they tell us that we need to get the present value. So let's quickly see what is the present value. If a compounded amount, future value is 10,000. Okay, so they tell us the future value is 10,000. And we basically are going to use the calculator with this one as well. So they tell us the future value is 10,000. So I'm putting a minus in front of that so that again, when I get to my answer of the present value, that now suddenly it's not negative. Amount future value is 10, invested 18% per annum. So my interest rate is 18%. So my interest per year is equal to 18% for 5 years. So we know that N is equal to 5. And interest is calculated monthly. So the times per year that this is happening is 12. So now it's important when you work out the present value that, again, there's the two ways of doing it is that your number of periods, like Greg said, he would have said 5 times 12 to get to 60, which is perfect. What I would do is I would say, okay, let's start on a calculator. My future value is 10,000. My interest per year is 18%. It is happening 12 times a year, so I need to remember that. It's happening 5 years, so it is 60 nearly payments of periods that's happening, and then my present value will be 4,092 rand 95.97. So rounded off, it will give me that. So Craig, did you, when you now tried with a 60 period, did you also get to the same answer?
Yes, I did.
Okay, cool. See, so keep that because I think that is, so with your method, you are getting to that, but I will check for you on the sharp to just get the other way so that at least you have both options. So again, calculator, very simple in how we did it, what was needed, where with a formula, yes, you will get to the same answer. So I don't think you must be scared of using the formula, but again, much easier to use the function of the financial calculator. Also interesting, and since it is an online exam, or basically home-based exam, or whatever you want to call it, you can look at online tools to assist as well. There's no difference in using a HP calculator that looks like a calculator, or using an HP calculator that's on a computer or in an app. So I think that is also important. You can use, if there's a calculator that you can download as an app, or calculator that you can use online, it is possible to do that. So I think the more options you have available, since we are doing it online, I think use those options. It's always good to have something in store if something else is not working. So basically, let's go back to this formula. So what I want to so we are now getting to all of these laws and things like that. So basically, what this definition is trying to tell us, and I think it's in the next one as well, is we are normally, the easy ones are normally the ones that they tell us, okay, you've got an interest rate, you've got a period, you've got a present value, work out the future value. That's easy. That's for the formula, that's easy. They tell us that, okay, you need to we give you the future like we did now, we give you an interest, we give you an N, you need to work out the present value. Again, using a calculator, using a formula, in a sense, that is easy. If we need to, they give us information that we need to work out the N, then it becomes more difficult if we need to do it manually. So basically definition 3.3, and you can see definition 3.3 is over 3 slides. That is basically to calculate if you need to get to N. And again, now it's easier to use the calculator for some of these calculations, the programmable ones, so that you can put in all the information, and then if you press N, you will get the answer of N. And I think so again, you can go through this because, again, if you look at it, and we can quickly do that. So if I look at the steps that we are doing here, and I think it's important that we just run through it quickly, because this is maths, and not all of you needed to have maths, and this is maths from way back. So basically, we want to get to the end. So the first step is, okay, let's see if we can isolate the N. So the first thing I would do is get rid of a P. To get rid of the P, you divide on both sides with a P. So we are basically getting that. So we get rid of a P. So now we're sitting with 1 plus I to the power of N is equal to S over P. For us to be able to take that to the front, we need to take logs on both sides. And now this is going to, or you would have done it in DSC1630 or in one of the maths courses. So you're basically taking ln or log on both sides. So to do that, you add len as a function. So now we have n not as exponent anymore to the power of something. We have it as a normal constant variable. So because we now done len on both sides, now we can say, okay, so what I need to do, get rid of on this side to isolate n is basically I need to divide by the len 1 plus 1, or 1 plus I, sorry. So that is basically then what you would have done. You would have taken that and you would have divided by the len 1 plus I. So then the long way now, if I give you the future value, if I give you the present value, if I give you the interest, you will be able to calculate the n without using the financial calculator for that. So it is possible if you want to play around with that and test it, it is doable. So let's, I think there was a question on this. So let's, and if you guys have your calculators, try it, but else I would also just quickly do it. So, and I'll write the things that I would have done now. And let's just see what we do get. I just want to quickly do it, and then I'll just explain what I did. Okay, so let's quickly just look at all of these things, and then let's get to answer. So after a period of time, 2,000 rand. So your future value, your present value is 2,500. So let's make that the -1. 2,500 will double. So if that is doubled, it is 5,000 at the end of a period. Okay. Then what it then tells you is half yearly. So how many times per year? It is 2. What is your interest rate? The interest rate is 11%. So you can add that as well. 11%. And then you can actually calculate n. And what do you get when you calculate n on your calculator? And again, I'm happy if you unmute. We are a small group, so don't have a problem if you unmute. So what do you get if you unmute? Oh, what's your answer? And if you want to tell me, unmute and no problem at all.
Okay,
Well,
so working it out just like that, John, sorry. Oh, it's fine. Damien can go ahead.
Now, like, I think we're basically going to say the same thing, Craig. On our, we basically have the same calculator. So you get, when you calculate n, just like that, you get like all the answer you're supposed to get. So you need to divide it by the period you get on your calculator.
Okay, cool. So Greg, is that also what you wanted to say?
Yeah, that's correct. I get 12.95.
Okay, so and the same on my side. So, and remember, so that is the number of times. So, and I think that again is the catch. So and trust me, that 12.95 would be one of your answers to select. Okay, so there's no ways that they will only give you the right answer and 3 other answers that is not nearly able to be calculated. So, and that is the thing, because we said half yearly, the 12.94 is how many times it happened during the years. So you need to divide by 2 because you said half yearly. If you used 4 and it was quarterly, you would have needed to divide your answer by 4. And I think that's, both of you are right. So that is nearly the catch in this one, is always remember what they are asking. So if they said how many periods, then the 12.95 would have been perfect. It would have been right. If I ask you how many years, then you need to say it is the 6.47 or whatever it was. So also let nearly the answer that you have, let that nearly guide you into what you need to get to. But I think that is for 1 year. Again, was easier with a calculator, but then you just need to remember with a calculator that there was a 2 times per year. But much easier with a calculator. If I needed to, and I'm not bad at maths, but if I need to do that, there's a chance that somewhere I will make a mistake. But you can use that method as well. Okay, so then some of the next ones just give you a bit more. So the other thing that we also look at is, so in this one, at what interest rate per annum must money be invested if accrued principal must triple in 10 years' time? Okay, so this one you can also do with a calculator. And a lot of times one look at this and say, but oof, they don't give me a present value, they don't give me a future value. But in this one, you can actually nearly decide what you want to use your future and your present value for. So if we look at exercise 3.5, what I normally do is to say, okay, let's make my present value is 1,000. And I put that into my calculator. Then the amount of money needs to be tripled. So I know that, okay, my future value, if my present value was 1,000, my future value will be 3,000. So then I can basically say, okay, my present value, let's just write it so that just is the minus 1,000. My future value is 3,000 because it's tripled. Okay, that is what I hope it means. So let's just do that. Then it told me the period of time is n, so we know what n is. Rate per annum, so now quickly see how the previous one, it was twice a year, so I now just need to remember that if I haven't reset my calculator, that I must go back to say 1 times per year. And then if I say press on the interest rate button, it must give me 11.6123. So basically what was added here was the N10. I must just remember to, so you would see me when I do these things, I would always just add that as a default nearly to say how many times per year, just that it doesn't mess with what is in the calculator's memory. And then if I press my interest rate button, I do get that number. Is that what you guys also got? So again, you can use the formula, but this is how I would have done it to make it simple. And you can, what's interesting, you can look at that present value. You can make it 100 Rand when you know your future value will be 300, and you will get the same answer. You can make that present value by all means 5 Rand, but because you need to triple it, you know that your future value will then be 15 Rand. You will get the same interest rate. So it doesn't matter what values you use for your present value, just multiply it by 3 for your future value, and you will get the interest rate that you need. And I think that is, with these types of questions, it's nearly one is stuck at, okay, but what must I use for my present value? What's my future value? And this was also a bit confusing. So I would have just made it as simple as it is here, to say my present value, it can even be 1 Rand. Then I know my future value is 3 Rand. Yeah, so the previous one we calculated N. Now with this one we calculated the interest. So both ways you can use the formulas that are provided, but you can also go back to your financial calculator that it's nearly built in already. Okay, are you guys happy with that? Give me a thumbs up if you're happy, that we can go on to the next part, or ask a question. Okay, cool. Okay, so let's go to the next one. So the next one is, the next portion looks at nominal and effective interest rate. And I think what is also important here is, in your exam, so by now, also what's interesting is they don't tell us in any of the previous ones if it's nominal or effective. So we assume that it is nominal every time until they tell us it's effective. So I think that is just the important one. And also what they do is I haven't seen nearly a question where they say you've got an effective rate and you've got a present value, work out the future value that you need to use for nominal. So that I haven't seen at all in any question. So that's not what you need to worry about. So it is more about, how do I convert the one into the other one? So it's purely on that basis. It's not to say that you convert it and then you use it in a sum to work out the future or the present value. I haven't seen any of that yet, so if any of you do, then you can send it on, but otherwise don't worry too much that you need to then use it in a future value or present value calculation. So basically, and let's look at again this example of how from the formula that we have, how we work it out. If we get the nominal rate, we can work out the effective rate. So basically we can use the formula for that. I also want to ask, so on my HP, I am able to use the calculator to change nominal into effective. So I just want to ask the guys that have a Sharp or Casio if you can do that as well. And again, unmute and tell me.
Yes, we can.
Okay, cool. So once again, that is what I would do. So I would again change it with a calculator without nearly going into the detail. But if we needed to use the formula, all that would have changed is every time that, so let's quickly do one. So they say it's at 22%. So we know that that would be the 22%. So a half yearly is 2 times a year. Quarterly is 4 times a year. Monthly is 12 times a year. And obviously daily is 365. So the only thing that will change in the calculations is the M. So if you need to work out the half yearly, M will be 2. If you need to calculate the quarterly, M would be 4. If you need to do it monthly, M would be 12. And if you do it daily, M would be 365. And you will see in your answers that it is actually very close to one another. So it will be that the one with the least amount of periods is always the smaller, just because if you look at interest on interest and things like that, obviously if it's only twice a year, it will be smaller than if it is on a daily basis. So how I would have done it on my calculator is, and again, that is where the how many times per year comes in. So I would have needed to change it on my HP as 2 times a year. Then I would have just put in the 22% as a nominal rate, and my second function, the effective rate, would then give me the 23.21. So if I needed to change it to a daily basis, I would have needed to say 365 times per year. The nominal rate would have stayed the same, which is the 22%. And then I would have also gotten the 24.5994, which would have been rounded up to the 24.6. So again, it is nearly, for me, easier to use the calculator if you can. Then you don't need to do this calculation. But this one is actually not too bad because you can just replace. So it's not, you must just remember that you work it out, you add the 1, then to the power of the how many times, then minus 1, and then multiply everything with 100 and how you use the brackets. And again, if you need to do it 3 or 4 times, it is a bit quicker to do it with a calculator as well. Did everybody try to do it? Again, I'll check on the Sharp and the Casio if I can get also maybe some manuals on that one, and see if we can share some of that as well. Okay, then that is how difficult the nominal and effective rate one will be. It nearly, if I look at previous exams, there are always one of these in the exams. So just be aware of that. Then the other things, so we looked in the simple interest. There was the section on counting days. So this is very similar in that it looks at not just counting days, but different time periods. And they love to ask questions like this. So again, if you look at exercise 3.8, so what they've asked is compare the amounts accumulated on a principal of 5,000 for 5 years and 3 months at 18% if simple interest is used for the odd period and compound interest for the rest of the period. Okay, so with this one, we can't just go straight to the calculator because that will not work. So you need to, for the simple interest part, you will still need to use your simple interest formula. So let's quickly look at it. So it is the 5,000. Your simple interest formula is that, so let's quickly look for 5 years and 3 months. So the 3 months would be your odd period. So it would be 3/12. So that is why it is the 3 divided by 12. It is that 3 months period. And that you multiply by the 18%. So that was from, if you remember, from a simple interest formula. And that answer we will add to 1. And then that we will multiply by the 5,000. Okay, so that would have given you the first part of that. The simple interest was used for the odd period. So that answer would have been 5225. So now what you can do is that 5225 you can use as a present value and use your calculator. So now you can go and say, okay, the 5225, that is my present value. This is run annually, so it is 1 time per year. It is for 5 years. Your interest was 18%. So then your future value will be, I got something different. So let's see, why did I get some? Oh, sorry, I'm looking at the wrong one. So then my future value is 11,953.53. So it is exactly the same. So after you did the simple interest, you get to answer, you use that for your present value, then you can use your calculator. So then you have your n that is equal to 5 because it is the 5-year period. So let's see where it was, that 5 years. It is, remember, 1 time per year and your 18% interest. So if you do that, you put that into your calculator, you will get the future value that is equal to the 15 or equal to that. Okay, but you can't, and I think this is important, for the simple interest, we will always need to use the simple interest formula. So no shortcut here in how you can quickly get to that first part of your solution, then to get to the answer. The other thing and the other formula that they use a lot, and I think that is also just important, is that, and this can also happen in the exam, that they ask you about a fractional compounding. So by fractional compounding, the only thing that they are doing there is to say, okay, well, we are combining the periods into one. So that there's not a simple interest calculation and then a compounding a compound interest calculation after that. So a fractional compounding, they're basically telling you use that whole period as your timeline. And that's why I think it's important again. So you would have drawn your timeline. That was for 5 years. Then you need to add just those 3 months extra in your fractional compounding component. 3 months over 12. So if we basically divide that, you will get 0.25. So some of your calculators again uses the fraction. Some of your calculators will show it as a decimal, again depending on what your calculator is doing. So your period is for 5 years plus the 0.25. So your compounding fractional period will be 5.25. And I think that is important in this instance. So that is where you will still use the same principle. You will say 1 plus the 0.18 as we have done with the formula that we got from way at the beginning, the compounding interest formula. So your 1 plus your interest rate, that to the power of then that compounding period. And then you will get the 11,922. And I think what is also very important is it's very similar nearly to the simple interest and the compound interest combination of the two. So it is not that there's a R1,000 difference or anything like that. Very similar nearly, that it is sitting at 11,922. Okay, so I think again important, and it can be that in a sense, oh, okay, it was posted way in the beginning of the chat. So if you go back in the chat, I hope you can, there will be an attendance register. I also posted the link to the attendance register and the feedback form somewhere in there, but it's nearly way at the beginning of the chat. There's a evaluation form and the attendance register form. So just, yes, for everybody that maybe joined in a bit later, there is a link to the attendance and the evaluation forms. Okay, so that part is the compounding, fractional compounding and the odd period calculation. So then the other thing that they also bring in is the continuous compounding. So again, I think it is very interesting and very, I don't want must use the word interesting. It is actually very complex and confusing because now they're using continuous compounding. The previous one was fractional compounding, and you need to nearly remember which one is which and which one to use when. So with the continuous compounding was nearly like the nominal and effective interest rate. And there again, it's seldom that I've seen that they ask you to work out the continuous compounding and then in the same question need to use it to work out a present value or future value. What they can do, and I hope they don't, but what they can do is, okay, that's weird. Okay, so let's quickly, sorry, I just want to, so please check if that one is, Oh, okay, cool. Let's just check. Thanks, Bronwyn, for also posting again. So again, with the continuous compounding, it's seldom that you will get that in one question they will ask you to use it for the same question. So it can be that, as a lot of these papers, there's like question 1 is work out the continuous compounding, and then question 2 is use that continuous compounding that you've worked out for the next one. Again, I don't hope so, but in this one, unfortunately, my calculator doesn't have an answer for this that you can just put it in. So you need to, unfortunately, use the formula. But at least the formula is not that difficult. So on your calculator, there will be the exponential or the e. So basically, you use the percentage, the 22%, so 0.22 as the x for that e. I would have gotten, if I put, so that, and let me, because they don't give that to you, that will be on my on my calculator, that was 1.2461. Okay, then you subtract the 1 as they tell you, and you get to 0.2461. And then basically, if you multiply that by 100, you will get to your 24.607777, which, if you round it off, will give you a 24.608. No shortcut here. There's no other way of doing it. You need to basically use the formula, and you will need to put in that interest rate into there to basically get to your continuous compounding. No shortcut with this one, unfortunately. Okay, so, and I think I did add, if I haven't, I will just check that I will add that to that slide as well for you. I will just check again that we cover all the formulas. So I don't see that one, so I will just add it to that last slide again for you when I share it. Okay, so then basically the other thing that we are working with is, so if we need to work out all the principal value P, all the future value S with continuous compounding, then you can use this formula. And I think what is important here, it's a bit different than your normal future value, present value. So this is the difference, is that here now, what they would have told you is you have a principal of, or your present value of 1,000. You have the continuous compounding interest rate of, let's say it was the 24.07%. And then they can tell you, okay, but what is then my future value? And I think also with a continuous compounding, you will see that you can also then bring in the t. So just remember then where that is in the period. So if I tell you if a period was 1, it's fine. We just use it as is there. But if I add a period, then remember, then you needed to say first, before you do anything, the 24.07 times the period. And then you work with the rest of the formula. So again, I think that is important, is to understand this formula and how to use it. Again, with a continuous compounding, we're not able to use the programmable calculator for that. We will need to use the formula and then substitute some of the values that they give you into that formula. Okay, we've got a few minutes, so let's quickly end up with the last exercise. I will need to update that formula page for you, but I'll share this so long, and then I'll send and I'll upload this later tonight to the team site as well. Before we get to that, I just nearly, okay, let's finish off, and then I'll just show my details again, that you can be added to WhatsApp groups and all those kind of things. So let's first finish this one, and then we'll get back to some of my contact details. Okay, so you decide now that when you graduate in 4 years' time, so nearly, we know n is equal to 4, they tell us in 4 years' time, you are going to treat yourself to a car to a value of 120,000. Okay, this was way back when cars was still very cheap. So your future value is 120,000. I wish that is what cars cost nowadays. If you can earn 15% interest, so let's put in the interest rate, 15%, that is your interest rate. Compounded monthly. Okay, so that's the first time that we now need to remember, okay, so this period that they are referring to is monthly. So when we put it into the calculator, we need to remember it's not once a year anymore, it's 12 times a year. So then what is your present value? And again, we can use a calculator. So I would start off with going to it 12 times per year, but I just know that is in. It is 4 years. So again, the number of periods would have been the 12 times the 4, so it will be 48 months. Your future value would be the negative 120,000. Your interest rate is 15%. So your present value is 66,102, and mine is 0.7786, because I always like to work with 4 decimals. So you would have seen that it is similar if I round it off, but by the calculator. So again, this was done by the calculator. I didn't need to go into the detail of the formula, and I do get the same answer. Damien and Greg, when you worked with a 48 period, did you also get to the same answer?
Yes.
Okay, cool. So I think that is, don't nearly change what you are doing, because you're getting to the right answers. So we've quickly ran through study unit or study unit 2, chapter 3, on compound interest. So basically, last week we did, let's just quickly do a recap. Last week we did the simple interest. Today we did for compound interest, and next week we'll start with some of the annuities and a bit more the difficult work. We'll use the calculator a lot next week as well. And then just the last slide for everybody again to see, if you're not on the WhatsApp group, please send me a WhatsApp and I'll add you to a group so that we can just, it's always long if we do this week by week. So if there's anything that we need to do in between the week, assignment questions that you struggle with, please send me a WhatsApp. We'll add you to a WhatsApp group. We also share other things on there that just makes it easier for you to get through the work. Okay. So that is nearly it for today. Quickly, if anybody wants to unmute and say and how it was, if there's things that I need to, and I know you've got feedback papers and things that you can, but if I need to change how we do this, if this is the way that you want to tackle it, that we go through a work that you understand it, please let me know. If you want to quickly give me feedback, that's also fine. I think the best way that we can get you guys to understand the work, the easiest for me to adapt. So if you're happy with this, we'll continue on this way, and don't worry about that we fill up the sessions. I don't have an issue if there's no more sessions left, but that we do an extra 1 or 2 sessions before your right exam to cover some exam papers as well. Okay, if there's nothing from you guys, have a great evening. If you quickly want to say anything, please unmute and have a chat. I don't have a problem. Otherwise, we'll see you guys next week again.
Thanks, John. See you next week.
Cool. Thanks, Greg.
Hi, this is Colin. I just want to say this class is helping so much. So thank you. I would love to join next week again.
Okay, no. So if you haven't, I see you are a guest. So let me, where was, so please send an email to the ctn@unisa.ac.za.
Okay.
That we can just get you registered, that then you can also see all the things that are posted on the Teams, and you can get access to things as well. So so please do that. When you can get into the system nearly, that you don't need to link on as a guest as well, and then you can get access to the things that I upload and things like that.
Fantastic. Thank you.
Cool. Okay. Thanks, everyone. Have a good evening and see you next week.